For mapping the data from the Caterpillar ECU and decoding it before it can be displayed on the Beijer HMI, let's open this document. C7 to C32 Electronics Application and Installation Guide. The objective of this video is to display these 8 parameters: engine percent load at current speed, engine speed, engine total hours of operation, engine coolant temperature, engine fuel temperature, engine fuel delivery pressure, engine oil pressure, and battery potential, plus the SPN and FMI for active diagnostics trouble codes DM1. Active diagnostics trouble codes DM1. SPN is a 19-bit number. SPNs are used to identify the specific component or system that is causing a fault. It is made out of 3 subparameters: SPN A least significant bits, SPN second byte, and SPN 3 most significant bits. 8, 8, and 3. The total length is 19, and that is how the 19 bits are allocated in 3 subparameters. Now let's move on to FMI. FMI is a 5-bit number. FMIs provide more specific details about the failure, such as whether it is a low pressure or high temperature, or a circuit problem. Now let's go over the A parameters that we need to map to the HMI. Engine percent load at current speed, 8-bit integer for data type, byte 3, length 8, units percent, resolution 1, min 0, max 125, identifier 0C F00300. The next one is engine speed, 16-bit float data type, byte 4 and 5, length 16, unit RPM, resolution again 0.125, min 0, identifier 0C F00400. Engine total hours of operation, 32-bit float data type, byte 1, 2, 3, and 4, length 32, unit hour, resolution again 05, min 0, identifier 18, FE E500. Engine coolant temperature 8-bit integer data type, byte 1, length 8, unit C, resolution again 1, min -40, identifier 18, FE EE00, and engine fuel temperature 8-bit integer data type, byte 2, length 8, unit C, resolution again 1, minimum -40, and identifier is also 18, FE EE00. Engine fuel delivery pressure 8-bit integer data type, byte 1, length 8, unit kPa, resolution again 4, min 0, identifier 18, FE EF00, and engine oil pressure 8-bit integer data type, byte 4, length 8, unit kPa, resolution again 4, minimum 0, identifier is also 18, FE EF00. And the last one is battery potential or voltage, 16-bit float data type, byte 7 and 8, length 16, unit volt, resolution again 0.05, min 0, identifier 18, FE F700. Now let's go over what we need to enter to the Excel sheet for DIM1, SPN, and FMI also. The identifier is 18, FECA00. The SPN is on byte 3, bit 1, 2, 3, 4, 5, 6, 7, 8, byte 4, bit 1, 2, 3, 4, 5, 6, 7, 8, and byte 5, bit 6, 7, and 8 only. The FMI is on byte 5, bit 1, 2, 3, 4, and 5 only. This is the HMI program folder that we just created. The tag or variable Excel sheet need to be in here, and it needs to be .csv. Let's open it. This is how the mapping information from the Caterpillar document should be entered on the Excel sheet before it can be imported to the HMI program. What we need to notice here is the byte and bit store from 0 to 7, while in the Caterpillar document they store from 1 to 8. So they need to be -1 before they can be entered on the Excel sheet. Now let's go over a few tags on the Excel sheet that I already entered, or the mapping and scaling information from the Caterpillar document. C7 to C32, Electronics Application and Installation Guide. The first one I have here is rx_load_rpm.word. .word is for 16-bit Word data type. Now let's go to page 131 on the Caterpillar document. For engine % load at current speed. For common, we have 92. 92 for SPN. For CAN identifier, we have identifier with the prefix OX 0CF 00300. This can be blank. CAN channel 1, send cycle millisecond 0, timeout millisecond blank, protocol J1939, controller blank, unit blank, gain 1. It comes from here. Resolution unit per bit. Offset 0 come from here, 0 for minimum. Data range blank. Additional information blank. For the bit addressing on the Caterpillar document, it starts from byte 3, bit 1 to bit 8, but on the Excel sheet it starts from byte 2, bit 0 to byte 2, bit 7. Bridge CAN 1 to CAN 9 can be blank. Priority blank. Always active 1. Power group 1. These green highlighted columns can be the same for all tags. Now let's check rx underscore engine underscore speed dot word. Dot word is for 16-bit data type, common 190, SPN 190, CAN identifier, prefix OX, and identifier 0C F00F00, gain, resolution 0.125, offset minimum 0, bit addressing byte 4 bit 128 and byte 5 bit 128. On the Excel sheet we have byte 3 bit 0 to byte 3 bit 7 and byte 4 bit 0 to byte 4 bit 7. Next we have rx underscore engine underscore total underscore hours dot double word d word for double word 32-bit data type. Common 247, SPN 247, CAN identifier, prefix OX, identifier 18 FE E500, gain, resolution 0.05, offset 0, min 0, bit addressing byte 1 bit 1 to 8, byte 2 bit 1 to 8, byte 3 bit 1 to 8, and byte 4 bit 1 to 8. But on the Excel sheet it starts from byte 0 bit 1 to 7, byte 1 bit 0 to byte 1 bit 7, byte 2 bit 0 to byte 2 bit 7, and byte 3 bit 0 to byte 3 bit 7. Now let's check these two tags for active diagnostics trouble codes. SPN and FMI 1214 and 1215 for SPN. Common 1214 and 1215. The SPN has 19 bits, so it cannot be a 16-bit word. Length 8 plus 8 plus 3 equals 19. For SPN, we have RX underscore ADTC underscore SPN underscore final dot dword. Dword is for double word 32-bit data type. CAN identifier prefix OX identifier 18 FECA 00 resolution 1 offset 0. For bit addressing, it will be byte 3, bit 1 to 8, byte 4, bit 1 to 8, and byte 5, bit 6, 7, and 8. But on the Excel sheet, we have it on byte 2, bit 0 to byte 2, bit 7, byte 3, bit 0 to byte 3, bit 7, and byte 4, bit 5 to byte 4, bit 7. For the FMI, we have RX underscore ADTC underscore FMI dot word. Dot word is for a 16-bit word. Common 1215. SPN 1215. CAN identifier prefix OX. Identifier 18 FECA 00. For bit addressing, it's on byte 5, bit 1, 2, 3, 4, and 5. But on the Excel sheet, it is on byte 4, bit 0 to byte 4, bit 4. This should be it for the Excel sheet. Save, close, close. Thank you for watching. If this video is helpful and you like the content of my channel, please like, share, and subscribe. A separate thanks at the lower right corner is also a great way to show your support to my channel. Thank you.